Hello everyone, my name is Cameron and welcome to my video tutorial on Assignment 0 for the Computer Graphics course on MIT OpenCourseWare. This is 6.837 and this was taught in fall 2012. So I got the idea to make this video actually yesterday. I was kind of clicking around on their website. Specifically, I like to go to department and this map right here, I love this map because basically like you can click around and see what the prerequisites are for each course. And it's just a big giant graph. So anyways, I found computer graphics on here and I've taken computer graphics at my university. So I wanted to see what their computer graphics course was like. So yeah, there it is, computer graphics. If you click on it, it shows you the prerequisites to get 8, 7. But I decided to jump right in since I've already taken computer graphics, and I noticed, well, the first thing I wanted to see was actually their lecture videos, but it looks like there were no lecture videos recorded for this semester, which is unfortunate. Like you'll notice over on this artificial intelligence course, there's video lectures, and these video lectures are awesome. It's fun to just sit there and basically audit an MIT class. But anyways, so we'll close artificial intelligence. I noticed they did have assignments with no examples, programming assignments, and I opened up their assignment 0 just to take a look down. And I was able to get the getting started working, and it wasn't as straightforward as you'd think. And since there's no videos for this course, I thought it would be worth it to make a video on each assignments for all the way up to the ray tracing. So we'll see how this goes. The structure of this video is I'm going to show you how to get the getting started to work. Then I'm going to pause the recording, and then I'm going to go through and do the requirements, and then I'm going to resume recording and show you how I got all of the requirements to work. And once I show you how to get the getting started to work, if you'd like to pause this video and try it yourself, feel free to do so. If not, you can just follow along all the way through. But yeah, so let's go ahead and get started. So they want you to download their supporting files, the starter code. I did not download this starter code for VC++, 2010 zip. I didn't download that. What I did download was the .gz, the tar.gz. And so here it is downloaded. I already have it downloaded. And I used 7-zip to extract it. 7-zip is a great program. I highly recommend it. It's basically like WinRAR. You know what that is. Anyways, you can even extract this compressed folder, which I already did, and it makes this 0.tar. Inside there was a .tar, and I extracted that. Then you get this 0 folder with all of these files. This A0 actually is what I created after getting the getting started to work. So it's not going to come with this start. Okay, so to work with this, you actually need to be running sort of Linux distribution, Ubuntu, whatever it is. I like to use the Windows subsystem for Linux. If you don't know what that is, or if you'd like to use exactly what I'm using to do this project, feel free to check out. I have a video tutorial on how to set up Windows subsystem for Linux on a Windows 10 computer like I have here. And if you want to see what it looks like, basically, you just have an Ubuntu app, and all it is a terminal. Because I used to use VirtualBox, and I would use virtualization to run Ubuntu, and I found that anytime I'd use that, all I really want is get into the terminal. I don't even really use anything else on Ubuntu except to jump into the Linux terminal. So, yeah, so if you want to learn more about that, check out my video on how to set that. I'm going to assume you have your own VirtualBox that you can download and work out of, or VMware, or whatever you'd like to use. Just get into a Linux terminal and we can get started from there. Yeah, so now that we have this set up, what else did I want to show you? Yeah, let's just get started. So you'll notice in here I have let me just make the font size a little bit bigger. too big, but whatever. Okay, so you'll notice I have in here just you know, a totally empty like Linux environment. How do I get into my Windows files, right? Because this folder here is located in my documents. So actually go into the mount folder. Mount. You can see the C drive, the D drive, and WSL. We're going to go to the C drive, go into users, and we can see my user here, Kirk. And we're going into, what is this called? MIT OpenCourseWare. Oops. Capital. OpenCourseWare. Oops, we got to go into documents first. Go into MIT OpenCourseWare. Okay, so I was looking at artificial intelligence, but since there are video lectures, maybe I'll do a series of assignments another time. But we're going to do computer graphics. So 6.8.7 graphics. Yep, and here we are. So I am now in the working directory for graphics. I'm also going to open up that 0 folder. Cool. So let me just do a make clean. I think this will work. Okay, so as a matter of fact, let's do this. Let me delete what I did. I'm just going to delete this guy. Start fresh. Delete this? Okay, pause the recording. I had my Visual Studio Code folder second. There we go. Okay, so now I can delete that. So now it's gone. And let's go back into. Okay, so we have that .tar 7 direct to cut this. Cool. And so there it is, as you would get it off of the website. I'm gonna go back into 0. So the first thing that the assignment tells you to try to do is, let's start off, just type make. And then it says on an Athena Linux station. So I'm not really sure what that is, but it says Linux, so we're going to do this in Linux. So whatever. Type make, and there's going to be an error. So vecmath. What the heck is vecmath? So I had to do some clicking around. And I will put this link in the description below. But there is a GitHub repository for vecmath. So I'll put this link in the video description if you want to get to this quickly. But basically, here it is, vecmath library from MIT's course in computer graphics. And that in a new tab. It says page not found. So the link is broken, but this is the course. Adapted for GNU Linux compilation installation. Excellent, this is what we want. So what you're going to do is once you open this up, you are going to click this clone or download and then click the little clipboard here. And that's going to copy this link to your clipboard. Back over here. And what I did, since I'm using Linux Subsystem for Linux, is I actually went to a different folder. I've already done this step, so actually let me get a second shell open, show you what I did. We're going to hide this one, bring this one up. Let me double check I'm still recording. Yep. So I did a git clone, paste in the link, and then dot here. And just to show you that that works, let me make a test directory, cd test, do a git clone, paste it in, and then what this is going to do is whatever folder you're in, this is going to download that repository. Cloning. Now when I do an ls, there's all this stuff. Awesome. So what do we do next? Next we can simply type make, and make, and what that just did is it made this output file. All right, and then I'm going to do make install. I'm not going to do this step, but basically you would push enter and it's going to do a couple of things. Now, what are those things that it's doing to your system? Let me show you, and this is important for understanding. If I view this make file is it's the code that's being ran for that make command. Let's open it up and see what's inside. So there's a lot of stuff we don't care. I want to see what happens when we click install. So there's the install. If you put the install option, this is what it's going to do. It's going to move the output folder, and it's using the wildcard operator. So basically it's moving everything inside the output folder to, there's a space here, it's moving it to user lib. And there's also a second move command that's moving everything, it's moving the vecmath to the user include vecmath. It's moving stuff into the user directory, which is in like the root file system. So since I've already completed this step, if I leave this folder and if I remove that folder, because that was just a test, you don't have to do this step. Not that. So okay. So there's my MIT. Okay. So if I go to where it says that put everything, go into lib, whole bunch of stuff in here, and there's some SO files. So somewhere in here is probably some stuff that compiled and built. Also in this folder is the include folder. And so inside here, we now have the vecmath. There it is. So that's what the make install is going to do. It's very simply just moving the stuff into, after you run make first, then you do make install, and then it puts all that stuff into your Linux file system, your root file system. So once you've done that, all right, we can close this guy. Back to where we were. I am back in the 0 folder. Once we've done that, okay, so we have vecmath, right? We should be able to make 0, but it still says it can't find vecmath. So what's really going on here? Well, the make file is actually printing out the commands that it's issuing to your computer. And if you take a look here, it's going into the user include. We just were there, getting the GL library. Also, it's trying to go into an MIT folder, 6.837 public include vecmath. That's not where we installed vecmath. And also, in my anywhere inside my file system, I don't have an MIT folder. This is probably a network folder for MIT computers. So how do we fix this? We need to modify the make file to point to the correct folder where vecmath is saved. So I just want to try something. If I type code dot, oh goodness, I don't know if I want it. Okay, luckily I didn't have a terrible time. I wanted to open Visual Studio, I wanted to open Visual Studio Code to basically edit the make file. And it worked. So typing code dot worked. That was, I shouldn't experiment. Anyways, okay, let me move on. I'm surprised that worked just like that. Okay, cool. Getting fancy over here. Okay, so the problem here is MIT, that doesn't exist. All of this stuff doesn't exist. We want it in the user folder, just like GL, because that's where we installed vecmath. And same thing for this guy. link flag. If we just want to user, yeah, I want to change this. Oops. Okay, save it. Okay, and then after we've saved it, I'm gonna leave this open. Let's go back to here. Now, can we type make? Okay. Now we have a different error, but different errors are good. So this one says cannot convert. Okay, so we're compiling main.cpp, cannot convert vector3. Okay, so this is on line 27. Let's see what this is all about. So we're gonna go into the main.cpp. By the way, this is the 0 folder. Main.cpp. So here it is. So I looked at this yesterday, and it's saying that these function inline void. It's saying that these functions can't compile. And then the comment here is these are convenience functions which allow us to call OpenGL methods on vec3D objects. OpenGL vertex and GL normal. And then it's taking a vector3f or vector3 float by reference, and it's trying to plug it into this function. So I did a little bit of Googling, and basically it's saying that like the function wants a GL float, not a vector3f. So I'm not really sure where this line of code is coming from, but and then also vector3f is a vector from the standard library vector of type vector3f. I feel like vector3 could be a class that I don't know where this is coming from, but I have some good news. If you simply give it a multi-line, okay, before we do a multi-line comment, I just want to show you, if I highlight the name of this function, nowhere else in the code is it used. So why are we declaring a function that's never used? And then also this function doesn't compile. That's why it's okay to comment it out. Your code is still going to work after commenting it. So simply give it a comment out. And if it ever comes back to bite us, then we'll figure it out. But for now, you can just comment it out, save it, jump back into here, and do a make. It makes. Awesome. So if you're using a VirtualBox or some sort of virtualization, Hyper-V, whatever it is, you can now simply do it /A0. If you're on Windows Subsystem for Linux like me, followed my tutorial, you'll know that you actually need to have some sort of X server app running so you can open up graphical user interface. If you try to do this right now, it's going to say, can't do it. So, you haven't seen that error before, but already running. So I'm opening up export 10, export the display, run it. Pause the recording. Okay, we're back. Some reason it gives a strange error when I don't run it as sudo, but if I run it as super user, then there you go. We got the T. Okay. Sorry, that really stumped me. I've never seen this error before, but apparently it is because yeah, I run it as super user. But yeah, here it is, assignment 0. So this is everything for the getting started portion. Once you successfully built, type /A0 at the terminal. It should open a teapot. Yes, that's all it does. It's now your job to make this application a bit more interesting by modifying the code. So I'm going to pause the recording here and try to go through the rest of the assignment and see if I can get it working. And then we're going to resume recording with the solution. Also, one thing to note is back on the step for installing the vecmath repository, you're going to download it, and then in this folder you're going to type make and then stay in the same folder, you're going to do a super user do or a sudo make install. You got to be as a super user, otherwise it's going to give you strange errors. So yep, we will be back and we'll talk about the solution. Okay, so I was able to get 2.1 working, which is just the color changes. I'm not saying my solution is the best, but it was the easiest code. I'm hoping that the other ones are going to well. But let's take a look at what I did. So add the ability to change the color of the displayed model. Right now, the color is set to blah, 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 which is a boring blue. Your task is to wire the C key to toggle through several colors. Feel free to choose which colors you want. How do you handle keyboard events? Notice that when you press keys while the application is running, the console says something like this. Unhandled key H, blah, 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 blah. Code prints these messages. Code that prints these messages, blah, 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 blah. I'm sure you've read all of this. Let's jump in and take a look at what they're talking about. So what I'm going to do is I am going to actually open one up that is unmodified so I can show you the steps I did to get this working. Okay, so main CPP. And we already talked about commenting out this line right here so that it compiles because we're not using it. Okay, so add code here for color change and then unhandled key press. So I changed this to change color and save it. Okay, so there is the draw scene method, and then I noticed here, and I'm sure you found this as well, maybe, there's an array of 4 colors, and you can add more if you want. And then it's just simply using first element in that array to set the diffuse color. So I also noticed they had int I here. Now, I am pretty sure that every time you run this function, you go into scope and a new I is created. And then once we're done, we're going to dump the image to the screen and we're done. And we leave scope, I is going to get deleted. So I was trying to think, oh, maybe I can make an index I to iterate through diff colors every time I push the C key. I was thinking maybe I could do this maybe in the main down here. But to be honest, I just wanted to get this done as quickly as possible. I also took a short break when I paused the recording. And so when I came back, I decided to simply make index I just a global variable because I'm lazy and this is not for a grade. I just want to see it work. So typically I've been told over and over again, don't use globals, don't use globals. So this is not good practice, but I think it's going to be okay here for the sake of our purpose. So I'll just initialize it to 0. Okay. Next up, we want to change color. Simply all we have to do is call the draw scene method that takes no puts. And then the other thing I did, I++. We're not done yet. Simply incrementing I. I thought about putting maybe some sort of logic, maybe an if statement where it's like, okay, if I is too big, put it back to 0. But since I'm lazy, I'm gonna assume that the user, isn't gonna have any overflow problems by incrementing an int many times. So I didn't worry about capping that because there's only 4 colors. So all I did here was instead of 0, I just put I mod 4. So this is going to be evaluated, and I will go 0, 1, 2, 3, 0, 1, 2, 3, even though I is going to be like counting way up more and more and more, taking the modulus 4. And that's everything. Oh, not quite, not everything. So because for some reason the code here given by MIT, they defined all of their functions one by one, and then they went to the main. The draw scene method is not defined when we try and reference it here. So better practice for MIT would be to do a void, do the function prototypes, keyboard func, and then give all of the options here, and give a prototype, and then move this declaration, all of these declarations below main, and give function prototypes, so that draw scene will be in scope and I can quickly modify their code. But because they did it this way, what I had to do was actually just take this entire draw scene method and cut it and paste it first so that it is defined first, so that it will be defined referencing. Okay, so save that. Those are all the changes. Let's see if this works. How do I get here? Yeah, so we'll clear the screen, and then what I'm going to do is actually navigate into that newly created one, 0.tar 0. So this is where we were working. Open up the directory for this. Open in File Explorer. That's in the .tar 0 folder. So yeah, that's where we are in Linux. And we're going to do a make. Oh wait, we also need to once again modify the make file since I started from scratch. So a make, this is going to be star. Okay. Oh, vector. Thought we that. That. Awesome. Okay, and then ls, and then sudo /a0. Boom. And push the C key, change color. There we go. Nice. So that's 2.1 done. All right, I'm going to pause. I'm going to make some more tea, and I am going to attempt to do the next one. Okay, I am back with my solution to 2.2. 2.2, yeah, and also I didn't read this for 2.1, but it says that they want you to use a global counter variable. So we did it right. I thought that there was going to be something a little bit more complicated to actually get this done, but nope, they're using a global counter just like us. And then also, let me pull that back up. So 2.2, add the ability to change the position of the light. This time we are... This can be done similarly to the suggested method for the environment. So again, using a global. So that makes it really easy. So I started to do it in here, but I have like 2 different versions. I want to do one where I can play around with it, and I want to do one where we together. Here's the one where we can do it together. And so this one has unhandled key press up arrow, blah, 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 up arrow, down arrow, left arrow, right arrow. So basically we can go up to the draw function, and this is the light position variable. And it's on line 77 because we put the draw method to first. I am also noticing that I don't think we need this function call here. I think we can get rid of it. Save. Let me get back into our folder. Oops. The 0.tar cd 0 ls clear make clean make, and let me see, where did we leave off? Yeah, we don't even need that line of code there. Yeah, so I++, and that was because I found that this line of code refreshes the display. So it was actually unnecessary to order these after all, because I was in a big hurry though. So we can actually put this one back. Put it back. I mean, it's not going to make a difference, but we could put it back just for the sake of having similar line numbers. Hoping it's back in the right spot so that. But anyways, nonetheless, none of that matters. We want light position. I'm going to simply cut it and put it all the way at the top, making it a global variable. Boom, there it is. Now that we've done that, then what we need to do is go back to our special function here. We can delete this guy. We can delete all of these output messages. We're not going to use it here. And then for the left, I started with the left. Well, yeah, so for the left, I'm not going to look at what I did. Remember what I did. What is the variable called? LT0 position. All we need to do, LT0 position. But, and I don't remember what I did, but we can figure it out. So index 0. So let's just change the first one by how much? What did the project say? By 0.5, increments of 0.5. So let's see what happens if we do a plus equal 0.5f. Save it. And this f means that it's a floating point value. Let's see what that did. So we can make clean, make, then run it. I push the left arrow. The light is moving to the right. So all that means is we want this one to be minus, and that means that we want this one plus, right? And let's see what that did. So clear, make, clean, make, and then run it. So we push the left arrow key, there it goes. And we push the right arrow key, there it goes. And then up and down arrow keys do nothing. Gotta get those guys next. So I went ahead and took a guess. Basically, we can put this guy here, why not? And we can put this guy here. Make this one minus and this one plus, and this time we'll operate on the second, why not, second index. Let's see what that does. Because we have index 0, index 1, and index 2. Now, I already know for a fact that this third one is going to be z-axis, and that's probably, well, it's not necessarily z-axis, but it's probably the axis that goes in and out of the screen. I don't actually know which axis is which. They could be labeled. It's arbitrary. It doesn't really matter. But I'm pretty sure that this third one goes in and out of the screen. Yeah, it's z-axis because the x-axis is left and right, y-axis is up and down, and y-axis is going down the screen. As it goes down the screen, it gets bigger. Assuming that's what we're doing here. At least that's what I've seen before. But anyways, it doesn't matter. So let's run this, see what it does on index 2, and see what that looks. Well, I'm not going to waste your time. We want it on index 1. Let's see what it looks like. Okay, so make clean, make, and then run it. So I'm pushing the up arrow, and it goes down. Okay, so that means all we need to do is simply these guys around. Assignment 0, this is so easy. So easy, so make clean, make, run it. Up arrow goes up, awesome, awesome. Down arrow goes down. Left arrow goes left. Right arrow goes right. Cool. Look at that full screen. Ooh. All right, let's take a look at the next one. I'm going to pause the recording and see if I can get this one working. And then I was thinking extra credit. I can leave that up to you. I'm not going to do that. Okay, I will be back. Okay, hello. And I'm back and I have finished part 2.3. Some time has passed. It's taken me a little bit longer, but a little bit rusty coding in C++. But nonetheless, I got it working. So we can talk about what I did to get it working. Let's see here. Oh yeah, 2.3 mesh loading display. So hopefully you've taken the time to read through this, but basically it's explaining what an OBJ file format is, an object file format, and it says it's a very common file format. So looks like this. You have a section with a bunch of V's, a bunch of VNs, and a bunch of F's. So V defines a vertex, Vn defines a normal, and an F defines, well, it's a little bit more difficult, but it defines the faces. And then it's in the format A, B, C, D, E, F, G, H, I. And then in this example, you can ignore B, E, and H, and you only need ADG for the vertice and CFI for the normal. And then it gives you a little code snippet of how you can draw a triangle using 3 vertices and 3 normals for those vertices. Cool. And then it goes on to explain how you can use vector from the standard library. So basically vector, you can put the type, and then you can just have a dynamically sized array. Well, it's not really an array, but it's a dynamically sized type. And then this is a method that's built into vector, which is pushback, and you can push an item into the vector. You can also pop, but I don't think we're using that for this assignment. We're only interested in push. And then here is some example code for iterating through a vector. So using the size for loop to go through the entire vector, do something with those things. And then we want to use standard command line in using Linux command line redirection. We're going to redirect the output of sphere.obj to our program and then use cn getLine a buffer. And they're going to use string stream, which I had to look up. I haven't used it before. Read the buffer as a string and read it as tokens. Then some example code of how you can read in. Also, how you can token v to do something. So a token basically is saying like it's going to give you a string without the spaces. So the space is the delimiter. Let's jump into the code and start developing it. Now for this one, I am going to reference what I did a few different times because I just got done doing it, but it was quite a long process. So the first thing I started off with was, notice there was a globals section. So we can actually move these globals up into the globals section. Cool, cool. And then the next thing is load the input here. This is where we're going to parse the our input file. I'm going to open up what I did here, and I'm going to develop this code again. Back up at the globals section, we define a buffer size. Fine. And I think we want a pretty big buffer size. Hashtag define buffer size I used. At the start, I did a buffer size of 50, but I am now realizing that way too. I ended up using a buffer size of 898. I have not spent any time looking into where this number comes from or if it's appropriate for buffer size that I need to read each line. But there it is. We can keep going from there. So we can go down to the load and start talking about reading, setting up our buffer and reading from it. So just like the example code they gave us. Take this. In. I'm not blind. Maybe I'll go to this side. Okay. Then we're going to make a buffer. Actually, a little bit of code that we're going to have to go through as quickly as I can so this video isn't too long. So buffer of buffer size, max buffer size. Actually, now that I'm thinking about it, that is a big buffer. We could probably make that buffer a little bit smaller. Let's do, betcha there's no more than 150 characters. Well, we can be safe. Let's do 250. That's a pretty big. We'll do 200. First time I'm trying to get this done. Okay. Now that we have a buffer, we're going to do a while loop. And this is while there is still a line to get. So cn.getLine. Put it in the buffer, get that line, put it in the buffer, and only put max buffer size character. Cool. So now we are in the loop. So this is where we're going to want to bring stream. This is another line of code given to you by the assignment. I can't just copy. Okay, yeah, so SS, what does it say? SS. You have string S, vector V. Let's type that code out. So vector 3F V and string S, right? And basically they're saying you can, once you have, so each iteration of the loop, you're going to get a line and put it in buffer, and then you're going to take that line and put it into a string stream, SS. And what that lets you do is take each token from that string, S. Then, so S is going to have something like V, and then we can also take the rest, V0, V, so let's look at, we open this in a new window. Look at an example here. All the way to the top. Okay, so there's the first token, V. This guy has V. The next thing is going to be a floating point number. So we can put that right into 0. The next token is going to be the next one. Next token is going to be the next one. That's how that works, right? And let's check here. Yep. Okay, and then we can say like if S is exactly V, then what to do is vect V, right? Because all the way at the top, vec V is our list of vertices. So vec V dot push back, right? V. So we're just going to push it on. Yep. Cool. New window. This guy is my solution. Bear with me 1 second. Sorry. Can I open anything? Okay. So yeah, all we have to do is simply push vector v, or sorry, push v onto the vertices vector. And then if s is equal to, so what's the other one? The other one is the other one is vn. And that's okay because we're taking an entire token, so vn is an entire token. Then instead we're going to push it onto, push back, not onto v, but onto n, right? Because vn, all the way at the top given to us, vn, the list of normals. Great. So easy part's done, right? One thing I do want to, okay, yeah, so what's the next thing? The next thing is handling these f's. So the f, okay, so if we get an f, what are we going to do? So this is the tricky part. I believe it even says that this is the part in the assignment. So what we're going to do is, let's see, let's look at that file format real quick. Okay, so that's an entire token, that's an entire token, that's an entire token, and then they're delimited by, the delimiter is the slash. So we need to do is actually only do this if we know we're a vector. Only do this if we know we're a normal, because if we're a face, we need to do some more parsing before. So we can't just like load up v and be ready to go. So that's why we need to do these conditionally. Okay, so now if we're in f, we need to take the first token and parse out the slashes. So I'm not going to take too much time explaining this code, but the code I developed, basically we're going to parse through each token and find the delimiter. So up here at the top, we can say our string delimiter equal to a slash. Yep. And then if we get an f, then we're going to take the first token and put it in s. And then now we're going to parse out the delimiters and save indexes. Right? Because each of these numbers represents an index. So this is the index for the vertex. This is not used because that's b. And then this is the index for the normal. Right? So A is a vertice indice A. C is an indice for the normal. It goes A, B, C, D, E, F, G, H, I. Okay, let's go ahead and do that. Yep. So I'm just going to put the code on the screen. This one. But basically, we're just taking out substring, excluding slashes. And then I will briefly talk about this code. Let me pause the recording and put the code up. Okay, so we have the code on the screen. Let's quickly run through here. We had to make another vector, an unsigned vector. Make that right here, a vector of type unsigned. Call it F. Right? Yep, unsigned. And checking. Because we notice up here at the top for the faces, it's a vector of type unsigned. So basically we have a vector of vectors, right? And let's look at the data that we're putting in here. So each face has 3 things that have 3 things. So a vector of vectors. Now, one thing that I did was I had just decided, instead of doing a vector of vectors, I did a vector of vectors. And what I'm saying is that basically every vector has a vector, and that vector has 9 unsigned ints, right? 9 here, A, B, C, D, E, F, G. Okay, and it says to ignore B, E, and H, but it's easier to just include them. Okay, so back over to here. I hope that makes sense. Leave a comment below and help out if you have any questions. But okay, let's go back down here. We have our vector of vectors, and we're going to have like 9 things. Okay, so we're taking the first token, and we're parsing out the slash and only taking the ints. Now, we know that it's not just the first token, but we are actually going to have 3 tokens. So we need to do this 3 times. So we can just simply put this code in a for loop. For int I equal to 0. I is less than 3. I plus plus. And whole thing up. Okay. So 3 times we're going to take the first one, set position 0, and go through and erase and take and push onto F an integer. So token's going to hold the integer, erase everything, and then do it again all the way until there is no string left. And then the very last thing is also going to be pushed on as itself. We're erasing everything. Then finally, we're going to push that vector onto the vector of face. There we go. We've just handled F. And I do believe this is all of the code. Let me just quickly check. This is all of the code that is going to be needed for loading. Okay, so let's save this, make sure it compiles, and then we'll move on. We're going to do make sure we're in the right directory, cd ls cd 0.tar ls cd 0 ls. Okay, so here we are. We're going to do a make, and it compiles, and let's make sure we can still run it. And we can run it. And we loaded up the gargoyle object. Pretty cool. So we loaded it, but we didn't display it. We're still displaying the teapot, right? So let's take a look at what else we need to get done. Get rid of that teapot. Well, for starters, obviously we want to work inside the draw scene function. And inside the draw scene function, there is this solid teapot. This is the GL2 method. GLUT method that draws a teapot. You should replace it with code to draw the object. So let's take a look at this sample code right here. This is going to draw 1 triangle, right? So let's put this up on the screen here, and let's kind of copy it down. GL, N, L, triangles, triangle. Okay, I'm going to pause the recording and put all of this up there. So we have exactly what they have. This code matches. But let's go ahead and define ints for A, C, D, F, I, G. And I am going to go ahead and copy that. Okay. Now those are defined. Now the other thing is we are going to have to all equal to, so A be equal to vector face, and we want to let's just take the first vector on our list of vectors. And what position is A? Well, right here, A is going to be position 0 because we start counting from A is going to be 0, 0. Quickly paste these guys. Also have to C, D, and we have F, G, and we have to do I. We need to get all of those values. So E is going to be position C is going to be position 0, 1, 2, position 2. So get the first vector, go to position. D is going to be position 3. 0, 1, 2, 3. You can see I'm counting from 0. F is going to be 0, 1, 2, 3, 4, 5, position 5. G is going to be position 6, and I is going to be position 8. Great. Now we have these indices for axes, those normal and the vertices. So let's see if this works. Let's see what this. Save it. Clean. Fake. Got an error because I have a. Oh, it's supposed to be triangle. This is the longest video I have ever made. Teague is setting in. Working all day on this. Okay, and there's nothing. And that's because we've only plotted one triangle. So we need to make a loop that's going to iterate through all of the triangles. So let's, oh, you know what? Yeah, it's okay. Everything's okay. Need to make this into a loop. So make a for loop, and this is going to be coming from sample code that they showed us here. This guy. So for unsigned int I is equal to 0, I is less than vec v dot size I plus plus, and make the scope everything except for the end. We want to basically all of the triangles. Have that in. Now I here, we actually can't use I because we're using I right now. So what I'm going to do is change that to Z. Okay, so instead of just taking the first one, we're going to iterate through all of them. And also this is not vec v, this is vec f for the faces. We're going to go through all of the faces. Hopefully this is right. So once we get these values, we put them in here, draw all of our triangles. Makes sense to me. Clean. Hope we can compile. I hope it works. Boom. And we have just completed everything required for this assignment. Now I am going to call it quits here and not worry about doing the extra credit. I will leave it up to you guys, but I hope you enjoyed this video. This is my first time doing this sort of video, and this took a long time. Been basically spent my whole afternoon on this. So yeah, hopefully you guys enjoyed this. I do plan on doing the next one, assignment 1, curves and surfaces. So stay tuned for that. Like, subscribe, leave a comment for any questions, and thank you for watching. Bye-bye.